So a Bernoulli differential equation has the form that's written here. You notice it's basically the same as a first order linear, except there's a y to the n term multiplied to the right-hand side. And it turns out that we are able to solve this type of equation by using similar techniques, but we are going to have to use a substitution as we're going to see. So to illustrate this, let's look at the equation that's down here. X times dy dx plus 4y equals x to the third y squared, where y at 1 is equal to 4. Now, because we want to model this after a first order linear equation, the first thing I want to do is divide both sides by x to make the dy dx term have a coefficient of 1. So we're going to divide both sides by x, and this is going to give us dy dx plus 4 over x times y is equal to x squared y squared. So the technique that we use, we divide both sides by the y squared. So we're going to divide both sides of the equation by that. And writing that as y to the negative 2, I'm going to have y to the negative 2 dy dx plus 4 over x. Now I have y times y to the negative 2, so it's going to be y to the negative 1 equals x squared. And that's sort of looking more like a first order linear, except we have these y to the negative 1 and y to the negative 2 terms. The thing to look at is, notice that if I look at this term right here, that, just want to pick a different color here, this appears to be the derivative. And remember that y is a function of x. If I take its derivative, I need to tack on a dy dx. So I'm going to let u equal y to the negative 1, and then du dx is equal to negative 1 y to the negative 2 times the derivative of the inside. So we're keeping the same independent variable here. Now notice, we don't have the negative 1, but that's okay. I'm actually going to say that negative du dx is equal to y to the negative 2 dy dx. So that means everything has a replacement now. So this u to the y to the negative 2 dy dx is the same as negative du dx. And going back to the green here, y to the negative 1 is equal to u. So I'm going to plug that back in. So we have negative du dx plus 4 over x times u equals x squared. We didn't touch the right-hand side. And now, again, looking like a first order linear, except we have a negative in front of the du dx, I'm going to multiply both sides by negative 1. So that's minus 4 over x times u equals negative x squared. Now, finally, let's take a first order linear. So now we do our integrating factor, which we call I, and that's e to the integral of the coefficient of u. And that looks like e to the negative 4 natural log x. We'll assume in this problem that x is positive, and that means e to the natural log of x to the negative 4, which is x to the negative 4. So we know the first order linear has a generalized solution. I times, well, in this case, u is equal to the integral of I times q dx. Always remember the IQ. So that means we have x to the negative 4th u is equal to the integral of x to the negative 4. The right-hand side q was here. That was x squared. So that's x squared dx. And that means we have the integral of x to the negative 2 dx, which is negative x to the negative 1 plus a constant. So that means we have x to the negative 4 u is equal to negative x to the negative 1 plus a constant. So to solve for u, we multiply both sides by x to the 4th. So we have negative x to the 3rd plus c times x to the 4th. So there's the general solution for u. Now what was u? u was y to the negative 1. So now bringing this back to the original variable, we have this. And truth be told, we could easily solve this for y because all that means is that the reciprocal of y is equal to this. So that means that y is equal to 1 over, I'm going to actually write it this way, cx to the 4th minus x to the 3rd. And didn't we have initial conditions to contend with as well? So I'm just going to scroll way back up to get those. We know that y at 1 is equal to 4. So that means when x equals 1, y is equal to 4. So we have 4 is equal to 1 over c times 1 minus 1, which means 4 is equal to 1 over c minus 1, which means 1/4 is equal to c minus 1. I'm taking the reciprocal of both sides there. And then c is equal to 5/4. So where does that lead? Our final solution, y is equal to 1 over 5/4 x to the 4th minus x to the 3rd. If you're looking for a slightly cleaner solution, you could multiply the numerator and denominator by 4 to eliminate the complex fraction. I'm not saying you have to do that, but maybe you'll want to do this anyway. So we would have 4 divided by 5x to the 4th minus 4x to the 3rd. And that is finally our solution to this differential equation. So Bernoulli can be a little bit more time consuming because of the substitutions, but as it turns out, it just boils down to a first order linear anyway. So thanks for watching, and be sure to watch out for more videos.